All right, we know how to graph sine and cosine, but what about the other graphs? That's what we're looking at today in 2-4, how to graph secant, cosecant, cotangent, and tangent. I want to start with tangent. The way that these are graphed is constructed the same way that the sine and the cosine were. They're based on the unit circle, and they are graphing coordinates versus angles. So our labels on the x-axis are the same. They are angles, and we're going to stay in radians. Please do not label in degrees. We're in radians now. And so here's how I'm going to label this. Pi over 2. This is going to be pi. This is 3 pi over 2. And this is 2 pi. Okay. What I want you to notice about tangent. Tangent is the y-coordinate divided by the x-coordinate. So the tangent of pi over 6, let me get a different color here, is 1 over root 3. That's the y-coordinate over the x-coordinate. The tangent of pi over 4 is root 2 over 2, which is 1. And the tangent of pi over 3 is root 3 over 1, which is root 3. When we get up here to pi over 2, the tangent is 1 over 0, which is undefined. So what that's going to do is it's going to create an asymptote at pi over 2. Okay, and I want you to notice something about the pattern here. Let's come over on this side. Y over x here is negative root 3 over 1, or root 3, negative root 3. Here it's going to be negative 1, and here it's going to be negative 1 over root 3. 0 over negative 1 is actually 0. It is defined there, okay? But when we come down into the third quadrant here, y over x is negative 1 over negative root 3, which is 1 over root 3. And as we go on, this is gonna be 1, and this is gonna be root 3. Look at what happens. You compare these two. Here's 1 over root 3, here's 1 over root 3, here's 1, root 3, root 3. So what's happening is these tangent values are only unique all the way around to pi, and then they start to repeat as you go in through the bottom half of the circle. So the thing I want you to realize about that is that the period on tangent is pi, whereas on sine and cosine it was 2 pi, tangent is pi, and it'll turn out that cotangent is the same. We'll go through that in a minute. But if you start graphing the values versus the angles, here's what tangent looks like. It turns to, it kind of looks like a cubic. Okay, it does this, and there's asymptotes at pi over 2, at negative pi over 2, and then it repeats. And it's got an asymptote at 3 pi over 2, and it looks like a cubic. And out here, a little past 2 pi, it'll happen again, and it's a tangent like this, okay? So this is its cycle. It's just a bunch of cubics. But the parent graph is this period right here. This is what we have just decided is going to be the parent graph. So you don't have to draw all these extra cycles of it as you go out. Just draw that one that's going through 0, 0. This is supposed to be going through 0, 0 right there. And that will be sufficient. And that's the one that you're going to shift and flip and do all the stuff to. Okay. Everything works the same with shifts, flips, amplitude, period, all that. Okay, the thing that's tricky with tangent is the period, so I want to look at that specifically. If we have y equals tangent of, let's say, 3 pi x. Okay, so the way you find the period is the same as last section. It's going to be the normal period over the number in front of x. So for our situation, the normal period of tangent we just saw is pi, and the number in front of x is 3 pi. So I divide that out, the pi's cancel, and my new period is 1/3. Okay, as we did it, what we did with sine is we just then relabeled the axis at 1/3. The problem is with tangent is that the first period of tangent straddles the y-axis. Okay, so it looks like this. This is our parent graph of tangent, and this value is pi over 2, and this is negative pi over 2. So because this graph does not start at 0, it means that this number right here is not the period, which it was with sine. If you recall, with sine, we started here at 0 and ended at 2 pi. So this first number that we marked was the period, but that's not true with tangent. What's happening with tangent is you have half of the period on one side of the y-axis and half of the period on the other side. So this distance on the left is pi over 2, this distance is pi over 2, and if you add them up, you get pi, which is the total period. So you can't just go and relabel this 1/3. That doesn't work, because that would mean that this distance right here is 1/3, and that would make the period a total of 2/3, which is not what it's supposed to be. It's supposed to be 1/3. Okay, so the idea with tangent is you have to figure out, oops, I just erased my axis. Hold on. What you want to do is you want this whole distance here to be 1/3. All right. So what is this label going to be? It's going to be half of a third. Okay, half of a third is a sixth. So that is the number that goes at this first marker. Okay, so let me erase the pi over 2, and if we're just relabeling, this is going to be 1/3. That's this value here, and this value on the left is going to be negative 1/3. I mean, sorry, I did that wrong. I said it right, and then I named it wrong. 1/6 and 1/6, because 1/6, that's this distance, plus 1/6 is going to be a total of 1/3 when you add those together. Okay, so on tangent you want this distance to be this period. That's the goal. That's the only tricky thing on tangent, and then everything else is the same. You know, if I add like put a +4 here, that's going to shift this guy up 4, and my little cubic's going to be up in the air more, or I could go right and left a certain amount. The amplitude, what the amplitude does in front of a tangent is it just makes this a little bit steeper, and that's pretty hard to really notice and grade, so I don't really pay attention too much to the amplitude on the tangent, but that is what it's doing. It's making it steeper. So for the most part with tangent, I want you to get your period shift right, your up down correct, and right left going. Now let's look at cotangent and compare how they differ. Cotangent actually does start at 0, so it doesn't have that same issue. And again, I'm not going to show you on the unit circle, but here's how it rolls. It's got asymptotes at 0 and at pi, and again at 2 pi. Now you only need to draw one period of this, but that's what it is, and it's a backwards cubic. Okay, so it goes down from left to right, as opposed to the tangent, which is actually a cubic, up from left to right. So this is what we would consider one period. So on this, because it starts at 0, if I have a period shift, like let's say my equation was y equals cotangent of pi x, I would take my period of cotangent, which is pi, and divide it by this number, which is pi, and I get a new period of 1. So I can just come over here and go, okay, this is now 1, and this is now 2. You can just relabel because you're counting straight from 0. You don't have to split it in half like you do with the tangent. Okay, shifts, flips, all work the same with cotangent. Let's take a look at secant and cosecant. Secant, if you recall, is the reciprocal of cosine. Okay, so the way that you draw secant is the first thing that I want you to do is draw cosine. And I want you to do all the flips and shifts that you need to do. So basically, whatever is in here, you just pretend like this says cosine, okay, to start with. And you draw that. So this is just a basic standard. So I'm going to go, cosine goes here, down, back up, and up to 1. So here's my cosine graph. Okay, now I'm going to extend this out a little bit so you can really see what's going on. Draw a little more than one period. Here's my extension of my, I did that a little bit too quickly there. There we go. Okay, so there's my cosine. I would shift this, I would flip it, and I would do the period change and the amplitude to it. Okay, once you're done and it's where it's supposed to be, the way that you change it to secant, okay, to get secant back, what you do is you draw asymptotes through the points that I call these the midpoints. They're the points that the x-axis is going through. And there's asymptotes through all of those. And then the way secant looks is it's parabolas then that bounce off the top and the bottom of your cosine graph. Okay, and then once you're done with drawing those, you erase the cosine because that's not actually part of the graph. That's just that. What that cosine does is it gives you a reference mark for where to draw your parabolas. And so this is the graph of secant. Okay, that's a parent graph. Now, I'm going to, cosecant works exactly the same way, only it works off of sine. And so I'm going to do one of those with some shifts so you can see what that looks like. And secant will end up being the same way. So let's graph y equals cosecant. Let's change the amplitude. Let's call the amplitude 2. And let's do a period shift and an upshift. All right. So if the directions were to graph this, what I'm going to start by graphing is y equals 2 sine of 2x plus 3, okay, which we did in the last section. So let's walk through this. Axis system first. Okay, and I'm going to go, my sine graph starts here, up, down, down, back up. Here's my one period of my sine graph. If you want to draw one more, you can. It's up to you. And let's figure out, I'm going to call this 2 because my amplitude is 2. So that's accurate. And for me here, each square will be 1. And let's figure out my period. The period of sine is 2 pi. And then I'm going to divide by the number in front of the x. So my new period is going to be pi. which means I'm going to come here to the end of my cycle and name this pi. Okay, and then I'm going to shift everything up 3. So let's do that in a different color. This point goes up 1, 2, 3, 1, 2, 3, 1, 2, 3, 2, 3, and 2, 3. All right, so here's my final. Okay, this is y equals 2 sine 2x plus 3. Now, what do I do for cosine? We're going to do this in pink, okay, or cosecant, I mean. Now we're going to change it to cosecant. So I find my midpoints. My midpoints are these points, they're the points in the middle of the peak and the valley, the top and the bottom. So, and that's where I'm going to draw my asymptotes, here and here. And then I'm going to bump my parabolas off the top of the orange graph and off the bottom of the orange graph. Okay? And then once I do that, I'm going to go in and I'm going to erase my guide markers, which were my sine graph, because that's not part of the graph. And the pink is what's left. Right, so that's how you do secant and cosecant. You are welcome, because we are online, you're welcome to use your calculators for this section. It will help you a little, but I am going to require that you mark these points exactly and mark your asymptotes, which your calculator may or may not show you. So please know how to do these by hand so that you can find the asymptotes and then use your calculator to verify that what you're drawing is correct. Right? Try some of these and we'll do some practice and answer questions in class.